Good afternoon, everybody. Welcome to today's lunchtime lecture. For anybody that doesn't know me, I'm Steve Constable, the current president of the IAgrE, and I'm standing in for Charlie, who's currently attending serials. So what we're going to do is, if you have any questions, it's in the chat. If you have any questions, please can you put it into the chat, and then we'll ask Tom those later at the end. So while they're often overlooked in the search for the best tractor and the most powerful engine, tyres play a key role in field work. They're the main link between the machine and the soil, and they guarantee security on slopes, facilitate better yields, and improve working conditions. Today, we're incredibly pleased to introduce our specialist, Tom Saunders of Michelin Tyres. Tom is a territory business manager for the Beyond Road business line for Michelin. And Tom is presenting what the impact tyres have on soil yields and profitability, different tyre technologies, and how to select the right tyre for the task. So without further ado, I'm going to hand over to you, Tom. Thank you very much.
Thank you, Steve, and good afternoon, everyone. Thank you for the introduction. And there's my first thing. Oh, here we go. So my name's Tom Saunders, Agricultural Account Manager for Michelin in the UK, and I'm speaking to you today actually from Clermont-Ferrand in France, our worldwide headquarters. And whilst we are a French company and our agricultural products are built in 3 factories in mainland Europe, in Tyre in France, in Valladolid in northern Spain, and in Olsztyn in Poland, we do in fact still have a manufacturing facility in the UK in Stoke-on-Trent, where our UK headquarters are, where we manufacture or remanufacture heavy truck tyres. So yeah, I'm a background in the agricultural machinery environment since going to agricultural college after finishing school, and the last 14 years within Michelin agriculture. And whilst Michelin make a tyre from everything from an Airbus A380 to a JCB telehandler and everything in between, I'm only responsible for agricultural products for my part of the UK, covering a territory that stretches, if you imagine, from Kings Lynn to Weymouth, everything in that sort of southeastern corner of the UK, if you drawn a straight line between those 2 points. So the first thing I wanted to do, guys, today is show you a very short video about tyre construction, because so often when we do these presentations, it's obvious to us that people don't really appreciate the technology and the different components and structure of a tyre and how a tyre is put together and built. You'll learn seeing this 3-minute short video on tyre construction, how a tyre is put together, and the same principles will apply, despite this being a car tyre video. The same principles apply for an agricultural tyre construction. So let's hope that the technology is going to play ball with me, and I'm going to be able to play this video.
A tyre is a complex assembly of many elements, implementing a wide variety of raw materials. The composition of the rubber compounds varies within a single tyre. Each compound is carefully developed to meet the requirements in terms of flexibility, resistance, grip, etc. Long lengths of metal and synthetic cable are also used. Manufacture is performed on the drum, a rotating cylinder whose central flexible section can be inflated for reasons which we will see later. The first element applied to the drum is a sheet of airtight synthetic rubber. This layer replaces the inner tube in today's tyres. In a second stage, a ply made of textile cords sheathed in rubber is then added. This network of cables will form a reinforcement radiating around the tyre. It is the radial carcass. Braced against strips of profiled rubber, 2 high-resistance metal cable hoops are installed. These are the bead wires. They will hold the tyre on the rim. The casing ply is folded over the beads to anchor it. Other elements are added. Sidewalls made of flexible, resistant rubber will protect the tyre from lateral damage. The tyre is then shaped by inflating the central section of the drum. Two plies are applied to the crown of the tyre. They are reinforced with metal wire arranged obliquely and, with the casing ply, form a network of triangles to limit the deformations of the tyre. Finally, the tread is fitted, the part of the tyre in contact with the ground. The tyre blank can then be installed in the curing mould. In the centre, a bladder filled with pressurized hot water pushes the still malleable material to the base of the patterns engraved in the mould. The heat of the water and steam surrounding the mould will cause curing to begin. The rise in temperature causes vulcanization of the rubber. The sulfur incorporated into the rubber compounds forms bonds between the polymer chains. At this point, the rubber switches from a plastic state to an elastic state. When removed from the mould, the tyre has acquired its definitive form and properties. Michelin, a better way forward.
To say that a tyre is made up of many different elements in terms of the different rubber compounds, the different oils and chemicals that are put into the product, the way those rubber products are blended, and then the way they're placed into the tyre to make it. So that your sidewall rubber is a very different compound than your tread rubber, and your inner butyl liner is a different, obviously a different rubber compound to the treads and the sidewalls. And so those different elements of the tyre are bonded together during the curing process, where the tyre is, if you like, cooked, where it goes into a curing mould and is cooked. And those different parts of the tyre are bonded together during the curing process. And that, for a typical agricultural tyre, let's say something like a 650, 6542, can take up to, say, 5 hours for that curing process to take place. And obviously a very energy demanding process in terms of that curing, a lot of heat involved, a lot of steam and so on. So some big challenges to us as a tyre manufacturer in terms of improving our efficiency and maintaining our competitivity with price by ensuring that we manufacture our tyres efficiently and so on. So let's go and start to talk about the markings on a tyre. And throughout the entire lecture, what I'm going to talk about isn't specifically related to a Michelin tyre. It will apply to whatever tyre you're looking at in the marketplace. So I wanted, first of all, to just recap on the millimetric markings that we see these days on our tyre sidewall. And in this example, we're looking at a 420/85/34. Equal, as it says there in old money, to 16,934. For those of us that have been around in the agricultural machinery industry a little longer, we'll have remembered something like 16,934 or 20.838. We're now moving to this millimetric marking, where we're seeing you're having the example like we see here, where 420 relates to the section width of the tyre in millimeters. The 85 is the aspect ratio as a percentage. So as a percentage of the section width, and then R denoting the tyre as a radial product, and 34 the rim diameter. So 420, 85, 34, common example that we'll see these days in an agricultural tyre. Cars are using the same size dimensions. I mean, I'm not a car expert, but 225, 55, R15. Truck is a good example of a truck super single is 385, 65, R22.5. So they all follow the same rules nowadays as we're moving to this millimetric marking. And just of interest, you see the 420 there. What we in the tyre trade, when we're measuring a tread width, or we're describing or talking about a section width, we're not necessarily talking about the tread width, but we're talking about the bulge on the sidewall, from sidewall to sidewall, when the tyre has got the reference load on it at the reference pressure. And that's what we measure as the section width in millimeters. So that's our millimetric marking that we're moving over to, or have been moving over to, over the last 10, 15, 20 years or so. And to give the tyre its full description, we've got to talk about the service description. So in this example here, where we're looking at this 420/85/38, PL telling us that the tyre is a tubeless type of tyre, and then the 142A8 and the 139B, jointly known as the service description. And these apply to the sidewall of again, every tyre, agricultural, car, truck, bus, and they are what we call, as well as the service description, otherwise might be known as the load and speed index of the tyre. And in this example, we're looking at a Cleaver tracker from our Cleaver range, because in Michelin, we have our Michelin brand, which is our premium brand, and then we have our Cleaver brand or Cleaver range of agricultural tyres, which is our mid-range offering to the market. So what do the 142A8 and the 139B mean stamped on the sidewall? Well, not a lot to us, because even I'm not haven't memorized the load and speed indexes of the tyres. But what we can do is show you here what they mean. Is the 142 tells us that the tyre is designed to carry a maximum load of 2,650 kilograms at the A8 speed rating of 40 kilometers an hour. And then this tyre has got a secondary load index where it's a 139B. So B being the 50 kilometer per hour speed rating, but at the higher speed, the load carrying capacity of the tyre is reduced slightly to 2,430 kgs, so jointly known as the service description. Reason being, at the higher speed, there's more heat generated, and so the carrying capacity is reduced at a higher speed to try and mitigate the effect of the tyre overheating. We'll all have driven down the motorway and seen a truck super single lying at the side of the carriageway, where a truck has, say, set off from Leeds to travel to London, and during the course of the journey, or even before the journey began, the tyre didn't have sufficient pressure in it. So as it was rotating at 56 miles an hour all the way down the M1, when it got to Luton, the heat got so much that the bonds broke down that had taken place during the curing process, and the tyre has come apart, delaminated and come apart like you see lying in the side of the road. The results are not as spectacular in the agricultural environment, but it can happen that a tyre that's run overloaded, underinflated, you can have the same issues if not running at the right pressure for the load. So those load and speed indexes, they're found in a tyre manufacturer's tech data book. So it doesn't matter if you were looking at a Trelleborg, but you had a Michelin tech data book, or you were looking at a Bridgestone and you had a Trelleborg tech data book. They're an industry standard and they're laid out in the tech data book. So again, don't mean anything to us stamped on the sidewall of the tyre, but get hold of a tech data book of any tyre manufacturers, and in there they will all be listed for you so that you can establish what the load carrying capacity of the tyre that you're looking at is, jointly known as the service description. So when we're talking about a tyre for the agricultural environment, we're looking for a good tyre specification that is going to provide the farmer, the contractor, with good grip and traction when he's working in the field. So he's able to transmit that tractor horsepower into effective wheel torque. As Steve said right at the start, you can have the most effective or the most powerful tractor in the world, but if you haven't got the right tyres to transmit that horsepower into effective wheel torque, then you're not going to get the best out of the engine horsepower. And you want to do that without compacting or smearing the soil so that you don't restrict crop growth and yield. You want directional stability when laden at high speed on the road. So many tractors these days are not only carrying out cultivations and seeding operations in the field, but then they're traveling at high speed on the road, hauling grain from the combine back to the field, or from the sugar beet harvester back to the clamp, and this sort of thing. So much more use at high speed, and even 65 kilometers an hour now becoming commonplace for us. Safety and comfort in the field and on the road. Obviously an important criteria, and satisfies regulations when operating on the road. You want to make sure that your vehicle isn't over width so that it attracts the attention of the authorities and makes life difficult for you when moving between fields and job sites and so on. And of course, being farmers, you're looking for good whole life costs. That's an important factor. So those all together will provide a good tyre specification for a tyre going into the agricultural environment. And the objective being to spread the load over as big an area as possible. This slide here, going back some time, probably a Fendt 818 or 185 horsepower, 180 horsepower. But look at the flotation tyres that it's equipped with there for establishing an autumn crop of winter wheat. You know, so consolidation, not compaction. So consolidation between the tread lugs, that consolidation of the soil and the ability of the tread lug to bite into the soil, giving the tractor its ability to make progress across the field. So where to start? Well, we've talked about the load and speed index, and that's important. I wanted to show you that because you've got to specify a tyre that's going to cope with the imposed load that you're going to put on it, or you're going to ask it to carry, and obviously the wheel horsepower and torque that you're going to put through it, casing, and then the road speed. You're going to want to make sure that you've got a tyre that's capable of travelling at the road speeds you're going to run it at. And then obviously the ground pressure. There's so much attention being paid now to soil, protection of the soil. So you want to make sure that your tyre is able to run at a pressure. Ideally, we would say as Michelin, between, well, at a maximum of 15 psi, ideally something between 9 and 15 psi. So that's where to start looking at how to select the right tyre. And then picking from the range of tyres to suit the farming operation, obviously the vehicle, the machinery, road use when laden. Is it going to be asked to cope with mounted equipment? So the axle weights when it's carrying mounted equipment to the field, obviously for the rear axle are much higher than if it was pulling a trailed piece of equipment to the field. So making sure that those axle weights are taken into consideration when making a specification choice. Trailed equipment, the nominal horsepower needed to pull the implement, and the soil conditions that you're going to be putting the implement through. So making sure that the casing is going to have the ability to cope with the power and the torque that's put through it. Obviously important. To give adequate capacity for the imposed wheel load with safety at maximum speed on the road, and to transmit the torque required at the wheels in the field with minimal slip. So that's what you've got to consider and you've got to weigh up to make an informed choice and to make the right choice when equipping a tractor with decent boots. So yeah, preserving the soil condition. So ground soil pressure. I put this slide in to talk about the effect the tyre has on the soil. So to summarise, in a correctly inflated tyre for the imposed load is approximately equivalent to the pressure in the soil. So for example, if I've got a tractor tyre that's running at 15 psi, we'd say you'd add to that a casing factor of 1 to 2 psi for a good quality radial tyre, for what we call the casing stiffness, and that'll be what's going down into the soil structure. So if your tyre's at 15 psi, 16 to 17 psi will be what that tyre's transferring down into the soil structure, and that's higher for a bias or a cross-ply tyre. We do still make a range of cross-ply tyres, interesting enough, within our sort of off-road environment, not for tractor drive, but for telehandler. We still make a range of cross-ply tyres for telehandler applications where they're going into the construction industry, where they're wanting a very rigid casing. They're wanting a casing that gives the machine great stability when they've got a pallet of bricks up at sort of 3 stories high. So those cross-ply tyres still have a place in the environment, as I say, for telehandlers going into the construction industry. So that's what you're transmitting down into the soil structure. And Gordon Spohr, who highlighted this many years ago, soils with high moisture content need tyres at low pressures. And when he talked about high moisture content, he wasn't talking about paddy rice conditions, paddy field conditions that you'd experience in Korea or Japan. He was talking about, you know, typical Northern European arable or grain field moisture conditions. You need to be working at low tyre pressures to protect the soil. And soil compaction, so again, how does it arise? Well, a lot of words on this slide, but if you can imagine that the soil structure is made up of many small particles of sand, silica, humus, broken down leaves and so on, and straw and debris left in the soil structure. And all those little particles should have, or ideally have got, air pores between them, so that air can transmit through the soil, so that water can pass through the soil structure, so that plants can put their roots down through the soil structure to access the water, to access the nutrients, to access the air that they need to produce a yield for the farmer. So those soil particles, as long as they're separate and they're not compressed and compacted together, then you've got a good soil structure. And water, however, that's stored in our typical Northern European soils, that's stored in the soil, it promotes the process of compaction because it acts as a lubricating film when the soil is travelled over, driven over, or walked over. It's important that operating at low pressure helps prevent the compaction action. And I mean, we've all seen it, haven't we, around a ring feeder in the middle of winter where cattle have been poaching the area, and come this time of year when the weather's turned hot and dry, that there's an issue there to be dealt with, where that pan around the ring feeder has got to be broken up and disturbed and so on to try and re-establish the soil structure. So damage occurs through four key elements, we could say, or four key actions during the yearly seasons of the farming operation. And those four actions are: one, the wheel load. So how high is the wheel load? Obviously extreme at harvest with sort of 18-ton, potentially 18-ton wheel loads on combine harvesters, and 23-ton wheel loads on sugar beet harvesters. So those sort of things. So that's our main and our first way of how the damage occurs. Then the contact area pressure. So again, are we traveling over that piece of ground with a tyre at 23 psi, or are we traveling over that piece of ground with a tyre at 9 psi? The contact area pressure being our second factor. The third one then being the traffic frequency. How often is that part of the field trafficked? And now obviously we're seeing a lot of interest in terms of moving across to controlled traffic farming and so on. So reducing or even eliminating traffic frequency on certain parts of the field and just restricting traffic to the traffic lanes that are set up in the field. And finally then slip. So if you're traveling across the field with a high percentage of wheel slip, then you're smearing the soil, you're damaging the soil, you're restricting plant growth by creating that cap on the soil through too high wheel slip. And it's not just cultivated soils. I've got to thank Tim Chayman from the Controlled Traffic Farming Group, who's supplied me with these photos. I think Tim took them when he was up on holiday in the North Yorkshire Dales, I think. But a typical, silage harvesting operation carried out on a field where no controlled traffic farming in progress, tractors and trailers driving hither and thither all over the field to remove the grass harvest. And, okay, at the time, these look like ideal harvesting conditions, dry weather, there's no mud or slippage occurring. But if we look at the field then a week later, you can clearly see where all the traffic has occurred and where those wheels have compacted the soil and restricted grass growth. And I suppose the point here in the picture being that grass will recover, but it's going to take some time. And you can see the areas which haven't been trafficked are growing away vigorously, whereas the rest of the field is playing catch up. And we could argue that the farmer's been onto this field since that harvesting gang left, and he's spread some fertilizer across it. And there's even been a shower of rain. We can see some moisture in the roadside gutter there. So we could argue that the fertilizer that he's thrown onto to those compacted or trafficked areas of the field, the fertilizer will have had a propensity to wash off in the rain that's followed and wash into the watercourse nearby, which of course is something that the Environment Agency and so on are very hot on. So yeah, it's not just cultivated soils where we've got to think about the impact of tyres and tyre pressure. Now, this is an interesting slide in that on the vertical axis, we've got our load in kilograms, and then on the horizontal axis, we've got our pressure from sort of 0 through the pressure range up to, say, 25 psi. And we've put in our marker there where I talked about the 1 bar or the 14 psi as Michelin tyres, where we'd ideally like to be making a recommendation to an end user that he runs a tyre at a maximum pressure of 1 bar. Ideally, he's running it between 7 psi and 1 bar. We've got a range of products now that enable them to work in that operating range. And, you know, typically, if we go back 20 years ago, sort of typical tractor tyre pressure would have been up at 23 psi, you know, conventional technology tractor tyres. But now, with the advent of IF and VF technology tyres, our Ultraflex product that Michelin were the pioneers with, we're able to offer tyres in this lower pressure operating range. And at the top there, then you've got a direct correlation in terms of soil compaction and wheel slip. We've talked already about the higher the pressure in the tyre, then the higher the damage you're doing to wheel slip, to the soil structure in terms of compaction, because you're running at a higher pressure. And likewise with wheel slip. If you've got a tyre running at 23 psi, the chances are that the radar monitor on the tractor driver's digital readout is going to be reading sort of 23% wheel slip. So again, if we can reduce the pressure in the tyre, we can reduce the wheel slip and improve the output of the tractor and its operation. So that slide really just showing how all those things are tied together, and how if we can get pressures down, then so much the better. We're going to be doing so much more to improve the operation on the farm. And if we talk about tractor product evolution, and we start, well, if we go back to 1997, when I was starting my career in the agricultural machinery industry, you know, typical tractor, 110 horsepower, I think was probably back in the day, the sort of average UK horsepower, typically traveling at 30 kph at top speed for a transmission, 40k just coming in around that time. Typical tractor, 5 1/4 tons, doing, let's say, 800 to 1,000 hours per annum. And the standard fitment around that time, something like a 20.8, 38 conventional technology tractor tyre. If we fast forward then to more or less the current day, we've seen an increase in powers now from like 180. I think the UK average now is something like 175 horsepower. So, but typically anything between 180 to 240 isn't considered extraordinary on a UK farm. Typically that tractor will have a transmission capable of doing 60 kilometers per hour. Chances are that tractor, if it isn't weighted at 7.25 tons in its base form, it's certainly equipped with the ability to put wheel weights on it, front linkage weights on it, and so on, to tip the scale at sort of 7 1/4 tons. Probably doing nearly 2,000 hours per annum now, a typical agricultural tractor on a UK farm, because there's less of them. They're being asked to be more diverse in what they do, whether that's hauling the beater's wagon through the winter months, to running a hedge cutter, to then you know, pulling up ground after harvest in sort of early September to establish winter crops. You know, much more demand being put on the tractor in terms of its working hours. But chances are that the standard fitment that's offered by the manufacturer is still probably a 20.8, 38. You know, okay, so that's the standard fitment. And unfortunately, a lot of farmers are very savvy to this now. They realise that the standard fitment isn't suitable for what they want to do with the tractor, and they're looking at alternatives to that to ensure that they get the best out of the tractor. So let's have a look then at a typical scenario of 4 different agricultural tyres. And in this slide here, where you can see 4 different tyres, all loaded to 3,800 kilograms. Okay, so that's the load we're imposing on the tyre in our scenario here. The 20.838 in orange there at the top of the slide, that tyre's maximum carrying capacity is 3,650 kilograms. So we're already overloading it by imposing 3,800 kilograms. We're having to run that tyre at 23 psi. Its footprint, as you can see on the far left there, is quite small, 2,500 centimeters squared. The casing is very rigid, so there's going to be a propensity for that casing to be cut, because it's very rigid. So if it encounters flint in the soil structure or so on, that flint's going to be able to cut the casing quite easily. The wheel slip is going to be quite high, sort of typically 23% wheel slip. So the rut that's being created by the tractor traveling on that car is going to be quite deep. So it's going to be burning a lot of fuel. We call it the bulldozer effect. You know, a rut 10 centimeters deep equates to a slope of 10%. So if we can reduce that rut depth from 10 centimeters down to 2 centimeters and reduce that bow wave of soil that is being pushed in front of the tyres all day long as you're driving across the field, and you're creating a rut, whether you're hauling grain off the combine on a baking hot day in August, or whether you're traveling across an autumn seedbed, let's say in late October in the drizzle, you're creating a rut. So to reduce that rut depth improves fuel economy, because it reduces the slope that the tyres got to climb up all day long. So if we look through the range of tyres there, we won't dwell on the 587 to 38, but let's look at the 650 65 38. Again, we're loading it to 3,800 kilograms. Our tyre in the 650 65 38 is able to carry 4,125 kilograms. So we're now within the carrying capacity of the tyre, so we can reduce its pressure from its upper limit of say 23 psi down to 17 psi. The footprint size is going up to nearly 3,000 centimeters squared. But looking then at the ultimate, our 710 60 38 Zeobib tyre has a 4.5 ton carrying capacity. We're only loading it to 3,800, so we can afford to reduce the pressure in that tyre down to 12 psi. Now, this is one of our new Ultraflex tyres. VF donates a very high flexion tyre, so it has a 40% ability to run at a 40% lower pressure than its conventional counterpart. One thing I forgot to say, guys, is that all 4 of these tyres, they all are equivalent tyres. So they're all the same diameter, or very, very nearly the same diameter, and they've all got a very similar rolling circumference. So there'll all be an option for our theoretical 130 horsepower tractor that we're say, considering here. So all 4 of these tyres, very similar in terms of their overall diameter and rolling circumference. They wouldn't necessarily all go on the same rim. You'd have to make rim changes to ensure that they fitted on the right rim. But you can see through that slide, I hope, I'm just giving you a flavour of going from a tyre at 23 psi for that load to a tyre at 12 psi at that load, and the footprint size, you know, nearly 4,000 centimeters squared. So really just illustrating the difference that the right tyre can make. And you know, if you had 2 identical tractors pulling 2 identical implements, one of them on the 710 60 38 Zeobibs and one of them on the 20.8 38 IAgrE bibs, we could argue that over the course of the autumn drilling campaign, that the guy on the Zeobib tired tractor would be home and parked up in the shed 3 days earlier than his colleague on the other tractor running the 20.8 38s, where he's slipping and sliding, high percentage of wheel slip, doing a lot of damage to the soil structure, burning a lot of diesel. So you know, all those things adding up to make the Zeobib the much better tyre option. So, and it's not just tractor tyres that we've got to consider, implement tyres as well. Here we see a typical scenario, okay, not so typical in terms of the ground conditions, but done to exaggerate the sort of benefits of running a flotation trailer tyre. On the left with the red trailer there on something like our 560 60 22.5 flotation trailer tyre versus a truck super single on the other side of 385 65 22.5, typically on an agricultural environment running at 90 psi, you know, and looking at the damage that tyre is doing at 90 psi, it just speaks volumes, doesn't it? That damage has got to be rectified once this trailer's left the field by carrying out some expensive subsoiling operations and then some cultivating operations operations and so on after that to re-establish the soil structure. Whereas the flotation trailer tyre, typically running at say 45 to 50 psi, sort of floating over the surface. And this one again, I put this slide in there. It's a flotation trailer tyre from our range of flotation trailers, but it's been used in an agricultural drive environment for a company that was equipping tractors to establish sports fields. You know, for Premier League football clubs and the like, you know, where they're going into a stadium and they want to preserve the structure of the sand that they're establishing the sports pitch on. And, you know, you can see that tyre, minimal rut being created there by that tyre, you know, carrying a sort of a grass seeder on the back of it, travelling over the sand seedbed that's been prepared. So tractor tyre choices, again, to suit the axle load and the tractor horsepower, the wheel torque that's going to be put through the rim and the tyre is important to consider. So we talked about our VF technology tyres. We've got a range of these now, launched back in probably, I'm going to say, 2006, 2005, something like that. We introduced the VF range of tyres initially in tractor drives like this. You see here typically umbilical slurry spreading, the ability of this tyre to run at 6 psi in that sort of application. No weight on the tractor, simply pulling the distribution head across the field. So the ability to get on the soil, you know, during times of the year when conventional technology tyres just wouldn't be able to enter the field. Seeing success with this product in self-propelled sprayers and the ability of the tyre to carry a terrific load for the likes of a fertilizer spreader and that sort of thing. So yeah, that's our VF ZeoBib range. What is this Ultraflex technology and how does it work? Well, it's all to do with the deflection zone of the tyre and the tyre's sidewall. We have a greater deflection zone, meaning the tyre is able to flex much greater than a standard or a conventional technology tyre, as you can see illustrated on the right there, the deflection zone of a tyre without Ultraflex being quite small. Its secret is in the way it's able to dissipate the heat that's generated running at the lower pressures, because obviously those lower pressures there's more flex in the casing and more heat being generated, but it's the ability of the tyre to get rid of that heat. So yeah, the tyre needs to be able to flex as much as possible under load for maximum contact area, to prevent soil damage, to prevent soil slippage of the wheel and so on. So our range of Ultraflex tyres now, we've got AXIO-BIB for tractors over 220 horsepower up to sort of 500 horsepower. Our ZeoBib range for tractors from 80 to 220 horsepower. The Cerex-BIB for our harvesting machinery that we get involved with. And the Spray-BIB is our Ultraflex crop spraying option. And we've introduced now Ultraflex trailer tyres in the last 2 years. So that's our latest developments there. So we've got, yes, this is an interesting slide that we put together after carrying out a 10-year-long study in conjunction with Harper Adams and the team there at Harper. Well, if every farmer in the world were to use an Ultraflex technology tyre with their ability to run at these lower pressures and their ability to protect the soil, then farmers would increase their yield by 4%. You know, so an extra 23 million tonnes of wheat would be produced if all the agricultural vehicles in the main wheat growing areas of the world were to switch to Ultraflex. So equating to Germany's annual wheat production there. So just some key stats that I thought you might like to use in summary, really, to the difference that an Ultraflex technology tyre can make to the farmers' improvement in productivity and yield. And our latest innovation, we've got, yeah, we're nearly there. I'm conscious of the time. We've got our EvoBib and central tyre inflation systems that we're bringing to the market. Michelin have acquired the company PTG in the last 3 years. PTG are a German manufacturer components and systems to equip farm tractors and farm vehicles with central tire inflation. So that's a very smart move. I think going forward, certainly 10 years time, we'll see a lot more farm vehicles being equipped with central tire inflation systems, I'm sure. I remember when I started my career in the industry, you know, or satellite navigation was something that was very much a small segment of the industry. But now I think probably 95% of tractors delivered to UK tractor dealers are probably, if they're not equipped with the domes ready to go, then they certainly got the hydraulics and the electronics plumbed into them, so that if the first owner doesn't take out an auto guidance option, then the second that ability to just plug in a dome and is ready to go. And I think we'll see much more involvement with central tire inflation systems as we go forward over the next 10 years or so. And finally, our Tweel is very exciting for us. It's a product that's an airless tyre. It utilises a polyurethane spoke to support the load. So in these sort of applications, in multi-purpose utility vehicles, side-by-sides, golf buggies, skid steer loaders and the like, zero-turn mowers, they have a puncture-free solution to enable them to work without fear of having downtime due to punctures, and that's something that we're very excited about. We haven't yet launched this sort of product for agricultural tractor environment, but who knows what might be coming in the future. So guys, I think bang on time at 40 minutes, Sarah. That's me summed up. Any questions from you guys?
Yeah, Tom, yeah, thank you very much. That was really interesting. So I'd like to kick it off. So you mentioned the Ultraflex tyre. My question was how have materials evolved with the more heavy, powerful tractors, but you're talking about the Ultraflex tyre protecting the ground. But my question is, what percentage overload factor do you put into a tyre?
Oh, that's a very good question, and one I'd have to direct to our technical manager to ask him that. We obviously have a technical data book and a technical data chart which illustrates the maximum carrying capacity of the tyre, and that's where we would start when we're doing a farm visit and we carry a weigh scale in the boot of our cars. So we're more than happy to go out on farm and put the weigh scale down, get the farmer to put his heaviest implement, whether that's a fully mounted implement or a trailed implement, get him to put that on the tractor, look at the maximum imposed load, and then establish whether the tyre he's got on the vehicle has got sufficient carrying capacity to cope with that. If it has, great. We then can look at advising him the pressure to run that tyre out. But that would always be our starting point. And I suppose we would always be making sure that the tyre's got sufficient carrying capacity in terms of that service description that we talked about at the start of the presentation, ensuring that service description had enough carrying capacity to cope with the load that we're seeing illustrated to us on the weigh scale when we've got the tractor on the scale.
That's very interesting. And I've also got one other, sorry, I'm hogging. So I'm in Lincolnshire, and since I've been here, we've had -16. And we've also had the hottest recorded temperature of 40.3. How do temperatures of that magnitude, I know it's not all the time, how does that affect the tyre life? Yeah, obviously exposure to very high temperatures, ozing, as we would call ozoning, certainly direct sunlight and high temperatures will cause the tyre to degrade in terms of the natural oils, or the oils within the tyre will tend to be transpired up to the surface of the tyre and evaporate off. We make the analogy that the tyre is very much like our human skin. You know, it's if you expose it to high levels of sunlight, high levels of temperature, and it gets burned, then that starts to degrade the rubbers and so on. And then at the other end of the extreme, the cold, I would say, isn't so much an issue for the rubber. Other than making sure that there aren't water ballast in the tyre to make sure that if it is, it's protected with an antifreeze solution and so on. Yeah, but certainly heat and direct sunlight has a big effect on
the effect on the tyre.
Brilliant, thank you. So I'm just going to have a quick look at the chat. So Tom, there's one here from Alan, and it says, I think you might have mentioned this, any thoughts, learning points for the company and farmers to share from the long-term research at Harper Adams on tillage and traction, currently well into the 4th PhD's research project? Alan, did you want to just expand on that one?
Yeah, sorry. Thanks, Steve. Yeah, you did. I sent it just before your excellent summary poster appeared. So all power to the Ultraflex. Yeah, I can take a point. Thank you. The other comment was a bit facetious, but I loved your quaint expression, hither and thither. I think that's one for Tim Chairman to use. We can pick up on, I think.
Yeah.
Okay, thank you. So William's got a question. William, did you want to ask this question yourself?
I think he might have. Did I see him pop up saying he's actually had to leave the meeting or something?
Was he?
No,
Oh, sorry.
I don't know, but I'm here. Well, I haven't got my camera on, but I'm here. In some circumstances, I think in front axles on buses, and I've heard it on trailers, there's a 10-year cut-off date. You know, like you may not use those tyres after that age in those circumstances. Now that strikes me as a very arbitrary date. Of course, if you've loved and if you've cared for your tyres and not used them much, they'll last 100 years.
Yeah,
but you haven't mentioned date at all.
Yeah, that's very true, William. I mean, that legislation was brought about after a catastrophic coach accident. I think it was on the A3 in between sort of Portsmouth and London, going back 10 years ago, where the VOSA guys inspected the tyres on the vehicle after the accident and found that one of the tyres or two of the tyres or something were sort of 16 or 18 or 20 years old or something. So that's very much a road legislation piece of legislation. In the agricultural environment, yeah, there's nothing to say to a farmer that he can't run a tractor tyre for longer than 10 years. Yeah, absolutely.
Yeah, I mean, I'm sorry, I'm not quite agriculture, but I'm very well aware of having a Austin 7 that has what I think is quite usable wheels, usable tyres that's probably 20 plus years old, or probably older than that.
Yeah.
But they haven't done much work, and they've been in the dark.
Yeah.
You know, in the workshop, sorry. Yeah.
Grain trailers being a classic example of that, and you know, used for sort of 4 weeks of the year and then parked back up in a shed for the rest of the time.
Okay, thank you.
Are there any other questions anybody's got? Okay, Tom, I'm going to throw one more at you.
Okay.
Can I just ask one more?
Yeah, sure. Go on.
In one of the last slides you showed a particular tyre for use on sprayers, which looks to me like a normal diagonal cleated tyre, but this is a pure non-driven. It's a trailer. Why have you chosen that, or is it just a good to grip the ground one when it's a non-driven driven wheel?
Yeah, indeed. The spray bib tyre is our Ultraflex row crop range. I suppose typically now we're seeing self-propelled sprayers at 5,000, 6,000 litres that have potentially got hydrostatic drive and so on. So primarily, I suppose that tyre, William, has been designed for those sort of scenarios rather than, let's say, a trailed sprayer with a non-driven axle. So yeah, and hence the reason it's got that pleated pattern.
Yep.
Okay, thank you. So you mentioned central inflation systems, which are quite interesting. If you're a contractor, you've got a tractor which you're using 50% on the road, 50% in the field if you're hauling tankers or something. Doesn't that make the tyre a compromise in one or the other situation? Because you can make the very best field tyre and the very best road tyre, and the variable pressure system obviously can help with that scenario.
Yeah.
But are you developing a tyre that's going to be, because there's a lot of people do a lot of road work.
Indeed.
Are you developing a tyre that would be for both, or have you developed it?
We have, in fact, yeah, we've got a product, Steve, called our road bib, which is if a customer comes to us and says he's spending 80% of his time on the road, you know, let's say hauling AD digestate or hauling green waste compost or chicken litter or something like that, where he's predominantly on the road hauling between a supply point in a field to tip the load or to eject the load, then the road bib would be a solution for him, because it's a tyre that's designed 80% road work, 20% field work. And so it still gives grip in the field. It still can perform in the field if he does have need to take that tractor off its tanker or its big trailer for a day to go and do some field work. But yeah, it's exactly that. It's a tyre designed for, let's say, 80% plus road work. Yeah.
Okay. Thank you very much. Thanks, Tom. Does anybody have any questions at all now? Okay.
It's Alan Plum. Just one last one. It is a little bit off piece, but watching tractor pulling is a passion of mine, and I just wondered, just enlighten us a bit how those guys, you know, what ratios they run and tire pressures and stuff.
Yeah, so the tractor pulling is a great application for seeing what the casing, the torque that the casing has to cope with, because you can really see that torque being put through the casing. I mean, typically, I suppose, Alan, I'm a bit out of touch with tractor pulling, but typically they're two-wheel drive tractors, aren't they? They don't have a, yeah. So and pressures wise, again, they generally are using a tyre, I believe, that's imported from the United States, where tractor pullings are, let's say, a lot more mainstream or has a higher profile, that are specially adapted with adapted treads on them, very shallow tread lugs and so on. So yeah, I wouldn't like to know what sort of pressures or pressure advice or power requirement they're designed to cope with. I did see in the UK at a recent show somebody not tractor pulling, but the monster truck guys that were running some of our Michelin Mega X bibs on some monster trucks for driving over cars and the like. And I hope they certainly get their pound of flesh, let's say, in the admission fees that they charge for an event like that to cover their costs. Because if one of those tyres punctures driving over a car irreparably, then they're on their own, I'm afraid. Yeah.
Okay. Oh, I think there's another. Please ask. Sorry, just 1 second. Oh, there's a direct message from Dio. It says, Tom, what's your view on IFVF tyres versus rubber tracks?
Okay, so rubber tracks, it's an interesting one. And in fact, I forgot to say it during the presentation, but Camso, who are one of the world's premium rubber track manufacturers, have also been acquired by Michelin over the last 5 years. So they're becoming part of the Michelin family of brands. Traditionally, we would have said that, you know, a rubber track, if you can imagine, let's say, a 500 horsepower tractor on a set of rubber tracks on a runway, and next to it a 500 horsepower tractor mechanical front wheel assist, you know, or what we would call in the UK a four-wheel drive tractor, what the Americans, I suppose, would more correctly call mechanical front wheel assist tractor, side by side. And you were wanting to push those tractors or pull those tractors down that runway to get them rolling. You could, in theory, almost hook up a Massey Ferguson 135 onto the front of the wheeled tractor with a chain and pull it down the runway. You'd struggle to do the same thing with the 500 horsepower rubber track vehicle, because it takes that much more energy to transmit the drive and to so you've got that disadvantage, if you like, in that the rubber track is going to be more power consumption hungry in terms of using more power to transmit the drive. So there's that. I'd also say that the modern Ultraflex VF technology tyres, ballasted correctly on the tractor, so making sure that there is sufficient weight on the tyre, because that's another important thing to consider, to ensure there is sufficient weight to get the casing to deflect and perform how it's designed to perform. But if you pay attention to your ballasting, pay attention to your pressures, I would say that a modern VF tyre would be putting down a footprint not as long as a track, but getting on for as long as a track, and giving, and probably running at a lower pressure. Coming back to that, when we talked about how damage occurs and traffic frequency, we could argue that with a track, the frequency is every time the tractor passes over a point in the field, it's trafficked 4 times, once by the lead sprocket, then the 3 idler sprockets, and then the rear sprocket. So whereas a tractor tyre, you're only trafficking or only making 1 pass with each wheel over that portion of the ground. So it's important to look deeper at the soil profile, and whilst the headline figure might be that the track is running at a low pressure or traveling at a low pressure over the field, it's important to consider the deeper soil structure damage that's being done by those multiple passes with those idler wheels and so on.
Okay. Well, thank you very much, Tom. I think we've come to the end of it. Thank you, Tom, so much for spending the time, and it's been really interesting. I've certainly learned a lot. I thought I knew what tyres were. Okay, so I'm just going to mention before everybody goes, the next lecture, save the date. It's Tuesday, the 11th of July. It's on recruitment and retention, and it's during this lunchtime lecture. Paul Harris, the CEO and founder of Real Success, is providing practical tips on how your business can stand out and become an employer of choice. So it's 11th of July. So please keep that in your diary.